Imagine a day like any other. You wake up, stretch, check your phone, and step outside, but something feels off. The ground beneath you wobbles, buildings appear to distort, and the sky seems to ripple like the surface of a pond after a stone is thrown in. You're not dreaming. Earth is being struck by a massive gravitational wave, an invisible force reshaping reality itself. What would happen next? Would we even survive? To answer that, let's dive deep into the science, history, and potential consequences of such a cosmic event. 1.3 billion years ago, in a galaxy far, far away, two colossal black holes engaged in a dance of doom. Spinning around each other at a mind-boggling 250 times per second, they spiraled inward, finally colliding in an explosion of unimaginable energy. The aftermath, a newly merged black hole, more than 60 times the mass of our Sun, and a shockwave of gravitational energy rippling across the universe. Fast forward to September 2015, that very wave, after traveling for over 1 billion years, finally reached Earth. Scientists at LIGO Laser Interferometer Gravitational Wave Observatory detected it using highly sensitive laser measurements. The discovery was groundbreaking, proving Albert Einstein's century-old prediction about the existence of gravitational waves. But this wave was incredibly weak by the time it reached us, merely nudging atoms apart by distances smaller than a proton. Now, what if such a wave were much stronger? What if a cosmic-scale collision happened right in our cosmic backyard? Gravitational waves are distortions in spacetime, moving at the speed of light. Imagine a vast cosmic fabric. When massive objects move or collide, they send ripples through this fabric, just like dropping a stone into water. These waves are produced by cataclysmic cosmic events. The collision of black holes, the explosion of supernovae, the rapid spin of neutron stars, even remnants of the Big Bang itself. Since their first detection, LIGO and its European counterpart Virgo have recorded over 50 gravitational wave events, each providing new insights into the violent history of our universe. But while these waves typically dissipate across vast distances, a close-range event would be a different story. What if two black holes collided within our own Milky Way galaxy? The effects on Earth could be catastrophic. 1. Space and time warped beyond recognition. If a powerful gravitational wave passed through Earth, space itself would stretch and compress. Imagine buildings momentarily shrinking or expanding, streets twisting and straightening in a surreal dance. Your very perception of time might fluctuate, causing bizarre effects like sudden jumps or slow-motion movements. 2. Violent geological and atmospheric chaos. At extreme intensities, gravitational waves could trigger massive earthquakes, splitting continents apart. Volcanoes might erupt globally, spewing ash and lava, while hurricanes and tsunamis rage unpredictably. The world would be plunged into an era of total geological instability. 3. A new form of climate change. If gravitational waves continuously impacted Earth, such as from a nearby neutron star emitting them regularly, our planet's climate could spiral into chaos. Constant energy fluctuations would create never-ending storms, heat waves, and freezing spells, making survival nearly impossible. To better understand these effects, let's look at extreme environments within our solar system. Example 1. Io, Jupiter's volcanic moon. Jupiter's moon Io is under intense gravitational stress due to its planet's massive pull. This stress causes extreme volcanic activity, constantly reshaping the moon's surface. If Earth were subjected to similar forces from gravitational waves, our world might resemble Io, covered in lava, toxic gases, and never-ending eruptions. Example 2. The tidal forces on Earth. The moon's gravity causes tides, gently moving Earth's oceans. Now, imagine a force millions of times stronger than that, stretching not just the oceans but the land itself. Cities could rise and fall like waves, and entire mountain ranges could shift overnight. Survival would depend on the severity of the waves and how often they struck. Here are a few possibilities. Mild waves. If gravitational waves only caused minor distortions, humanity could adapt, building flexible structures designed to bend with the fluctuations. Moderate waves. If earthquakes and storms became regular, underground cities or off-world colonies on Mars or the Moon might become our only option. Extreme waves. If the planet itself was torn apart, survival would be impossible. Our only hope would be escaping to another star system beforehand. Gravitational waves teach us that the universe is an ever-changing, dynamic place. While we may feel safe on our little planet, the cosmos is filled with forces beyond our comprehension. Here are some key takeaways. Science and preparedness. Understanding these cosmic events helps us prepare for the unknown. Space exploration is essential. As Carl Sagan once said, extinction is the rule. Survival is the exception. We must expand beyond Earth to ensure humanity's long-term future. Perspective on life. The vastness and power of the universe remind us to cherish our existence. Compared to the scale of the cosmos, our daily problems seem insignificant. For now, we can breathe easily. The nearest black hole collisions are far beyond our solar system, and the gravitational waves we detect are too weak to harm us. But as we explore deeper into space, we must remain aware of the unpredictable nature of the cosmos. And this raises another question: what if gravity itself suddenly disappeared? That, my friends, is a story for another time. As you go about your day, remember that right now, at this very moment, invisible ripples from cosmic collisions billions of years ago are passing through you. The universe is alive, in motion, and constantly reshaping itself whether we feel it or not.